All right, so let's start talking about modules. Modules are very important pieces of code, and you can think of a module as a way to separate code to try and make things simpler. We're always trying to look to separate things and to make them simpler and easier to read, similar to how I'm separating all of these files into each of their own modules. So let's take an example of module using Terraform. So here with this module keyword that I have, I've specified a module that I'm going to be getting my code from. So this is going to get code from right here. If you go over here, this is just a self-declared module. It exists in my own repository, so it's a pretty simple one, but it just comes over here to the modules.resource group. And we have our own set of code here. You can see that it has its own Terraform code, outputs, variables, it has everything right here. So if we go inside of main, we see that it has all of the code that it was going to create for the resource group. So it has the name, it has the location, and it has the tags. Now, when you are calling a module, you need to provide it with everything that it asks for. And the way you know what it's going to ask for is by going into the variables and finding out what all the variables are. So this module is going to request a name, a location, and tags. Now, you will notice that for the location and also for the tags, I have some default values here. Similar to how we did it before, those are going to be the values that they will be if no other value is specified. So right here, when I've declared my resource group, I could leave the location and the tags to both be empty. I could just remove them like this. And then it would use the default values that are declared right here. But let's say that I want to keep this environment production tag inside of it. So now it's not going to use whatever is written here. It's going to use whatever I've declared. So you can think of the defaults as just a bit of a fail-safe. In case something goes wrong, this is what they're going to use to try and make it work out. Something like the name of the resource group, that's pretty hard to determine what the default value should be. So it's best just to tell the user, hey, I need a name for this resource group. And then since that's such an important element of this, we need to make sure that they provide it. And if we run a Terraform plan and a value isn't provided, then it will throw an error and will say you need to provide a value for this. So then it takes all the variables that the user has passed in and it creates it. So if I go to my declaration of this, the name of the resource group, the location that I put in it, and the tags that I've put in here is what it's going to populate into all of these values. Now, I spoke before about outputs, and this is where outputs are going to shine. This is where you're going to see why outputs are so important. So in addition to creating this, I am going to provide output values, and these are values that can be accessed from inside of the module. Because normally the only information that you're able to get is just inside of this module. So this module has a name, location, and tags, and you can only use those inside of the module. That's it. But outputs, these output values of the module, provide a way for you to be able to get information about the module. Whatever you want to be an output, you need to declare it here. So I've just picked all the values that I put in. I picked the name of the resource group, the location, and the tags. You can see that I specify the resource that I created right here, Azure RM resource group main. And then I do Azure RM resource group main, and then I specify what variable I want from that object or that resource, which in this case is a location. So this is important because we need these values. Now it's possible that we could just guess what the values are, but it's better for us to have references to them. So if I go over here to my virtual network, which is likewise calling a module called virtual network that I've declared in my own repository here. So I already know what the location is. But a better way of doing this, just to make sure, is that I can specify that I want to get one of the outputs from the resource group module. So the way I would do this is that I'd go over here to resource group. We have the module keyword, and then we have the resource group. And then if I come here, we have module dot name of the module, which is resource group, and then the outputs that we want, which we got from here, because we know that one of the outputs is the location. You have to match these exactly correctly. So you say module, name of the module, and then the name of the outputs that you want there. And now with this, I'm able to get the location from the resource group. I could just say East US, I know that's the value, but it's better to do it this way. And same thing here with the resource group name. It's saying, hey, what resource group should we assign the virtual network to? Well, if I specify that I want the resource group module and I want the name of the resource group, then that's a very reliable way of doing this. And the same thing with the tags. Depends on is a bit of an important thing. It is a way of building dependencies. And what this is saying is that it will not run this code until the module.resourceGroup has been run. So when I run my Terraform code, it's going to make sure that it runs this code first. And then because I have the depends on, that specifies don't do anything until that's finished. And then we take all the values that we've passed in here. We pass in the address space, we pass in the address spaces for the subnet, and we pass everything in for the virtual network. And we can once again go to the variables to see what all the values are that it wants. Values that have default, we don't have to declare, so they're optional, in other words. But in this case, I am going to be specifying them for this. And then it goes ahead into the virtual network. I split this up into two different resources. Before it was one resource, but now we have the virtual network, and now we have the subnet. I specify the outputs that I want. So I want the name of the virtual network, I want the ID value of the virtual network, and I want the subnet ID value. So that in that case, if other modules need those values, it can need them, such as with the AKS here. This one doesn't need one from the virtual network module, but it does need some from the resource group module. Module resource group location, module resource group name. And then same thing as we did before, we are specifying two modules. So this one is not going to run until it knows that module resource group and module virtual network are both done. Now we could just remove this right here. We could just keep it to this, module.virtualNetwork, and that would be enough because we know that module.virtualNetwork is not going to finish until module.resourceGroup has run, and then the module AKS won't run until the module.virtualNetwork has run. We have the same thing here. Some of these values are hard-coded. We might want to switch it into doing maybe var type. I haven't declared that variable in the variables here, and it's not being passed in this module, so that's creating an error. But if I wanted to make that something that people who use my module can modify, then I can do that. So you might be asking yourself, why do we make modules? Why don't we just declare everything in the project that we have? Well, it's always good to separate things so that it can be more easily read. But another huge advantage behind using modules is that it's easy for all different kinds of people to use them for all their different kinds of projects, environments, and scenarios. So pretend that up here I have my module, which is about the resource group. So this module is all about creating resource groups. Now, project 1 and project 2 both need to create resource groups. So I just have to declare the code once here in the module, and I can make this really advanced. I can make it a very good module. I can make it have rules that it has to follow. I can make it so it has variables, maybe security checks, pass things around to sensitive values. And now Project 1 and Project 2 don't have to worry about all that stuff. The only thing that they have to worry is about grabbing the module and inserting the values that it's going to ask for, and then it's able to take care of all the hard work for them, and it's easy. So we can use this across all the different projects that we have, and it's going to be a real boon for our project to just not have to repeat so many things that we've done. And it's even better in cases where you have sort of a separation of duties with the different people. Maybe some people are in charge of just the module, some people are in charge of just Project 1, and some people are just in charge of Project 2. So these guys can handle the module code so that you can just focus on your project and you can take care of everything there. Now, all the modules that I have shown to you up until this point have been self-declared modules. They're just modules that I built. They were very simple modules. There's a lot of things they didn't cover. But this, the one that I'm showing you right here, is a much more commonly used repository. Terraform Azure RM storage account, as the name implies. This is a module that you would use to use Terraform to create storage accounts on your Azure subscription. So this has had a lot of effort put into it. You can see all these contributors here. A lot of people have been here. They give a lot of specifications about things that you would need to have. They say when you use Terraform, make sure you're using at least this version. When you're using Azure RM, make sure you're using at least this version. Same thing with random. They specify what resources it can create, what inputs it's going to be asking for, and this is a lot. This is pretty complicated. But I have this in my code where I am going to be calling this module. So before you start using the module code, you should follow along with the different processes that I was explaining before. What can you do with the module? You should check the README out. You should see the variables file and see what are all the different variables that it's going to be asking for. Do any of them have default values? This one creates a certain type of storage account. So you want to look through all of this, and you want to make sure that you're passing in all of the correct variables. You will also want to go to the different releases that they have. As you can see, this has 31 releases. And generally speaking, using the latest version is the best. So they have version 1.2.0. They specify everything that they've done since the last one. So since the previous version that they released a few months earlier from that, they specify everything that's changed. So when you use the later versions, if you're upgrading from an earlier version, let's say I'm using version 1.10 and I want to upgrade to 1.20, then I should be mindful of all the different changes that they've made from those versions so that when I upgrade it, I don't ruin my code. Now, I have an example here of me calling this module. So I decided to call the module storage account, and then I specify what the source is. You can use this format to call these modules. This is the SSH way of doing it. There are a couple of different ways of calling the modules, but whenever you specify these things, you have to specify the source code because you have to be getting code from somewhere. And then this is all a bit of syntax stuff that you'll become familiar with as you've tried this out. Azure Terraform Azure RM storage account, which is the name of the GitHub repository. And then this is very important at the end right here. So I have this reference right here, and I am specifying that I want it to use the latest version. Now I can specify a different version. I can do 1.10, I can do 1.00, I can do any one of them that I want because all of them are available. So if I want to use an earlier version, then I have the option of doing that. I don't only have to use versions, I can also use branches. So I can use the main branch. Maybe if, let's say, there's another branch that's called develop, I could use develop branch. I can have my own branches that I make. Let's say I made a test branch. So I can put that in there as well. And I can test some things out. I can make some modifications on that branch because it's my branch, and I can see what different behaviors take place over it. But you want to go for a version, because a version, the code cannot change. Once a version is released, the code cannot change. It's possible the version may go down, that someone may take it down, but generally speaking, the version is the best way to go because the code cannot be changed. So I'm using the latest version of it, and I can specify all different kinds of things. I can specify even a commit message that I'm trying to use. So I can look at a specific commit when the code was in a specific setting. Now, the reason you don't want to use branches and commits is because those are much more likely to be dangerous. Because if I were to point towards the main branch, then that means the main branch may have some changes that will happen to it that I didn't know about. So if I change it to main, and I run my code and it works and I'm happy, and then I call it a day, and then I come back the next day, somebody suddenly made changes to main. Well, that's a problem because now my code is going to behave differently, and it could behave in a very bad way that could ruin things. So if I try to run the Terraform plan and apply again, then this may have unforeseen changes. So pointing to a branch is risky and not recommended because it could change. But if you specify a version, that won't happen. So with this version that I have, I pass in all the variables that it's going to be asking for. These are just some random things that I've decided to pick. With my storage account, I give it a resource group that needs to be created in, a location, some tags. I decide to make it not accessible to the public, so I make that false. I specify what kind of storage account I want. IP list, some service endpoints that make it so that these are things that can connect to my to my storage account, and just all these things. So this is an example of a much more complicated module. In future videos, we will be covering more about what these things are capable of. But these are modules. Modules are very important parts of Terraform code. Another thing that you will need to be aware of with these modules is this right here. I was talking a little bit about it earlier before, but they will say that these are providers that you need to have. So Terraform, Azure RM, and Random. Now, luckily, I have specified what those different values are right here. I have the Azure RM version and I have the random version, and then I wouldn't be able to write all of this code unless I were using Terraform. So I have all of my values here, which is good because that's what the module is asking for. But you need to be aware because sometimes they might be asking for providers that you don't have. So if they ask for Kubernetes or Helm providers, for example, you need to make sure that you have those installed. My modules here are very simple, so they don't have a providers.tf, or sometimes it's called a versions.tf, that is required for these modules, but other modules will have those specifications.